Hi everybody, it is Sam from the GSLAC STEM team. I want to thank everybody for joining us for tonight's Virtual STEM Fair Award ceremony. In order to celebrate you guys all tuning in, we actually have some really special stuff to show you. I actually have some dry ice with me here tonight that I'm going to show you some pretty cool stuff with. Some of you might know a little bit about dry ice already, some of you might not. Dry ice technically is not water. There is no water inside of this piece of ice. Instead, it is made out of carbon dioxide. Now, you might know carbon dioxide as a gas that you exhale, that you breathe out. It is a colorless, odorless, tasteless gas. Normally, it is just that, a gas. However, in order to make a piece of dry ice, you actually have to get that gas down to negative 109 degrees Fahrenheit. That is 109 degrees below zero. So this piece of dry ice in my hand is incredibly cold. You might actually be able to see some signs of it being very cold. One, you might notice every once in a while I'm changing hands because it is so cold. The other is you can see a little bit of this kind of fog or steam coming off of it. Now, another reason that this is called dry ice is because it does not melt. When it gets hotter, it does not turn from a solid to a liquid. Instead, it does something called sublimating, which means it goes from being a solid straight to a gas. So I want to demonstrate for that to you guys today. I have a whole bunch of pieces of dry ice in my container here. I'm going to use a squirt bottle filled with some warm water and just spray it right over the top of my dry ice. You can see when I spray it, it starts to sublimate quicker. It starts to make more of that gas. If I actually lift this up, you can see the gas stays inside of this container. That is because the carbon dioxide we are making is heavier than air. Because it is heavier than air, it is staying inside of this container. And this does an excellent job of showing us that gas is actually a fluid, meaning it flows. You can see I can make waves inside this container. Not only can I make waves, but I can actually pour this carbon dioxide out of my container. Awesome. So, actually, to prove to you guys that our dry ice is sublimating and going from being a solid to a gas, we're going to put a couple pieces inside of our empty balloon here. This balloon was completely empty before we started. I'm going to add just a couple pieces of dry ice. I'm going to very quickly remove my glove to tie off the top of that container. Again, I'm wearing gloves because of how incredibly cold this dry ice is. I'm going to tie off my balloon, and then we will come back, check in on this in a few minutes later on in the presentation. Awesome. I'm going to go ahead and put my glove back on and show you some of the other cool properties of dry ice. So we already showed how when we heat it up, it starts to sublimate quicker. We actually saw that kind of fog or steam come off of it. We mentioned that carbon dioxide is actually a colorless gas, a clear gas. You can't actually see it. So what you're actually seeing when we spray the dry ice, that kind of steam or fog coming off it, is not carbon dioxide, not the stuff you're actually seeing. There's carbon dioxide with it, but what you're actually seeing is water vapor, which is gaseous water. So what we're going to do now is I have a glass of water right here. I'm going to go ahead and plop just a few pieces of our dry ice right into that water, and you can see it starts to sublimate pretty quickly. You can tell it's sublimating. We're actually making a gas because there are bubbles in the bottom of that container coming up to the top. Again, what we are seeing, this kind of fog, is water vapor, but there is carbon dioxide in there. If you know something about carbon dioxide, you might know that it is actually used in fire extinguishers to put out fires. We can actually use this carbon dioxide we're making to put out a fire here tonight. So what I'm going to do is light a small candle Remember not to try any of this that you're seeing at home. I'm going to light that candle, and I'm actually going to pour a little bit of this carbon dioxide that we are making into an empty cup. And then I'll show you, if we pour this over our flame actually goes out. The carbon dioxide in there did not allow oxygen to get to that fire, so our fire burnt out. And that was all just using the power of the carbon dioxide that we are making in this container. Now there's one more that I want to show you before we move on to our next event, and that is I want to actually have you listen to something. I have some quarters over here that have been sitting on this table. They're a little bit warm. They're definitely warmer than our negative 109 degrees Fahrenheit dry ice, and I'm actually going to touch our quarter to our dry ice, and I want you to listen to what you hear. All right, ready? So you probably heard a little bit of a screeching sound. You can actually see on this piece of dry ice, we've almost kind of sawed a mark into this piece of dry ice. And what was happening there is that hot metal, that warm metal, when it touched that dry ice, got it to sublimate, turn into a gas much, much quicker. As it was turning into that gas was coming off of that piece of dry ice. As it was coming off that piece of dry ice, it wiggled the quarter in my hand. It shook it back and forth. If you know anything about sound, you might know that sound is made by vibrations. By that coin vibrating back and forth as that gas escaped that dry ice, that is what made that squeaking, screeching sound. All right, I hope you enjoyed that. I will see you in just a little bit with some more dry ice demos.